Welcome back to SATCO Lighting Basics. This is session 2. We'll start off with dimming, where we left off from the last session. Look at beam spreads, warranties, foot candles, and LED replacements for screw-based lamps, and then have a quiz. Do all screw-based LED lamps dim? That's a great question. Let's find out. Dimming. We're so used to A19 lamps dimming that when you add an LED to an A19, you assume it dims. Well, some can be dimmable, some may not dim, and it would state that non-dimmable. If it is dimmable, the dimmer needs to be compatible. And in this example, there's a link to all our compatible dimmers. If the dimmer is not compatible, then it will not dim properly. Okay, a little bit of a comparison and steps you can take to ensure that dimming LED is successful. As I mentioned, all incandescent and halogens dim down to 1%, and they get warmer when they dim. Incandescent dimmers are inexpensive, but they're not compatible with LED lamps. In order for a dimmer to be compatible, it needs to be on the list of approved dimmers, and it needs to say it's approved for LEDs. General service LED lamps will dim, if they say they're dimmable, down to between 10 to 25%. General service LED lamps do not change color when dimmed. The color temperature remains the same. As they dim, your eye may interpret it as getting a little bit warmer, but if you check the color temperature with a meter, they'd be the same. So it will not get down to that candle-like color temperature that a restaurant or a homeowner may want. If they want those advanced features of color temperature changing when dimming, there are other products that are available, and Starfish is one of them, which can mimic incandescent and halogen dimming. So in order for the LED to dim, it must be dimmable. The dimmer has to be has to be approved. And just for reference, there are two types of dimmers. Forward phase, common names, phase cut, triac, C.L, or reverse phase. Again, common names, ELV, electronic low voltage, or trailing edge. Let's just look and see what the differences are. Okay, what does dimming look like? Well, you take an AC sine wave and you put it through a dimmer, and if the dimmer is forward phased, as the sine wave moves away from the zero line, you will trim that portion of the voltage in order to dim the lamp. Note, it moves away when it's rising, and it moves away from the zero line as it crosses, and in both areas, anytime it moves away from the zero, the voltage is trimmed. That's forward phase. In reverse phase, the opposite happens. As the sine wave moves towards the zero crossing, the voltage is trimmed, whether it's heading towards it or going through its peak and then down towards the zero line. This is the portion of the waveform that's trimmed. Forward phase in the beginning of LEDs was not recommended because it didn't work very well. But with the evolution of dimmers and the amount of LED lamps that are on the market now, forward phase lamps do a very good job of dimming LEDs. And so do reverse phase. Is there a better one? I'd say reverse phase probably does a slightly better job, but the key is to look at the lamp, find out what dimmers have been approved for it, and most times you'll see both forward phase and reverse phase have been approved. So if it's approved, it will work fine. Here's an example of that 11 watt LED that we've been comparing it. Notice there are 20 different types of dimmers that will be approved. Some are C.L, forward phase. Some of them are ELV, reverse phase. Again, both can do a good job. The key is find the lamp, look up the approved dimmers for it, and things should work fine. Lamp life. In the comparison between the halogen lamp and the LED, we noticed that the halogen lamp was rated at 1,000 hours and the LED was rated at 25,000 hours. Let's look at the other sources and their lamp lives. Incandescent halogen is the shortest. Compact fluorescent can get up to 20,000 hours of life. Linear fluorescent, up to 35,000. Metal halide, approximately 20,000. And high pressure sodium, some lamps can get up to 40,000 hours. For all those lamp types, the measurement is that 50% of the lamps in an installation will have failed at the lamp life stated. 1,000-hour lamp, if you've got 100 lamps, 50% of the lamps will fail within 1,000 hours, and the rest will go on and go for some other period of time. LEDs are not calculated that way for lamp life. LEDs will usually last much longer than what the lamp life is stated. For an LED, the lamp life means that 30% of the light has depreciated, and there's lumen maintenance. So if the lamp starts out at 10,000 lumens, it will get to approximately 7,000 lumens at the number stated for lamp life. Lamp life is in hours. How many hours are in a year if you're running them 24/7? Approximately 9,000 hours. That'll be a key number when we look at return on investment, or how much can you save if you replace a inefficient lamp with a more efficient lamp. Most lamps and fixtures have warranties, and LEDs range from 3 years to 5 years. And this includes stipulations about maximum hours that they can be burned per day. LEDs and all lamps have exclusions for mishandlings or misapplications. In an LED, temperature plays an important role in meeting rated lamp life, and warranties will state the minimum and maximum temperature allowed. LEDs may also state a minimum compartment size, and this is to ensure that the lamp has enough air in the compartment to stabilize and to stay under the maximum temperature allowed. As I mentioned before, legacy lamps is called a mortality curve. And when 50% of a large group of lamps have failed, that is their end of life, and that's what their life number is based on. If lamps fail early, SATCO may ask for samples and or visit the installation should product failure become excessive. Here's some examples of LED lamps that are each assigned a specific warranty. So one lamp is a 3-year warranty, and it may state 3 hours per start, and that's for a specific lamp that is rated at 15,000 hours. Each of the lamps in the SATCO line has a specific warranty conditions to meet that 15,000 hours of life. Same thing holds true for another lamp. Here, the next lamp down, it's a 3-year warranty, also with a 15,000 hour life rating, but here you can run the lamp at 10 hours for start. The next lamp, LED lamp, it is rated at 25,000 hours, has a 5-year warranty, and it can also be used or operated for 10 hours per day. For our high pro lamps, they are also 5-year warranty. Their life is rated at 50,000 hours, and those lamps can be used for 12 hours per day. All of the stipulations on warranty are on our SATCO website, and it specifically notes warranty information and the restrictions on that. Should you have an application that's 24/7, contact SATCO so we can discuss what lamps would best suit that installation. Lighting industry or electrical terms. I'm sure you know many of these. So what's UL or ETL? Well, it's a third-party testing company that certifies the safety of the product. Weather. We say some lamps are damp, some of them are wet rated. But what does that mean? Damp, the lamp must be shielded from direct water contact, so it can't be left out in the rain for the moisture to get on it. Wet can be directly exposed to moisture. Another category is called IP ratings, and IP ratings can be related to damp and wet. An IP rating of 44 is what we call damp, and a wet rating would have an IP rating of 65. I suggest if you deal in these categories that you go to the website and type in IP ratings. There you'll see a full listing of what the IP ratings are. The first number is for objects and the second number relates to moisture. RoHS means restriction of hazardous substances, and it has to do with substances that may be in the product that are not very environmentally safe. What's a smart light? The ability to receive commands through wireless means and then take those commands and change some parameter of the light source. Utility rebates. They've been in the lighting industry for 20 plus years. These are utility sponsored incentives that reduce energy consumption and supply the end user with rebate dollars to reduce his return on investment. I'm getting a little ahead of myself. Return on investment is the cost of the total project cost divided by the energy saved, usually in months. And usually any project under 4 years is determined a pretty good return on investment. Foot candles. That's how we measure the light that we need for certain activities. And it's lumens per square foot, and we'll get into that a little later. How would you know how many fixtures to put into an application? Well, there you do a lighting layout, and it's calculations to determine what foot candles are needed and then how many fixtures or lamps need to be in that space. Who decides what the foot candle is? Well, ultimately the user, but guidelines are published by the Illuminating Engineering Society in documents called best practices. And these can be looked up on the web or refer to the best practices to determine the number. Bypass ballast. As the name states, the lamp does not use the existing ballast and the ballast is taken out of the circuit. And control or controls. These are devices mostly used in fixtures that modifies the light output to include turning it off. Beam spreads. Beam spreads offer directional lights or directional fixtures. They give you an indication of how the light emanates from the fixture or from the light source. The lower the degrees in beam spread, the tighter the control of the light, as you can see in the picture. A 15-degree beam spread is on the left, and you see how narrow that is. As you go up in beam spread degrees, 24 degrees, the beam gets a little wider, 36 degrees, 60 degrees. And there's a table on the right that actually names the differences in degrees and puts a name on it. A very narrow spot is under 14-degree beam spread. A spot is between 15 and 25. Floods are approximately 40-degree beam spreads, and wide floods are degree beam spread over 60. And as the beam spreads out, you get less light across the whole beam face. So the 15 degrees would give you the most intense light, and the 60 degrees would give you the least intense, but it would be spread out over a larger area. Here's some examples of beam spreads in par 38. Center beam Candela tells you how much light is right below the center of the lamp. So it's light in one direction. That's the most amount of light that you will get out of the lamp in any direction. For the 25-degree beam angle lamp, the center beam candela is 2000. For the 40-degree beam angle, the center beam candela will be 1300. So less amount of light in the center, more light spread out over a larger area. And for a wide beam spread 60-degree angle, notice that the center beam candela drops to almost half of what it would be for a 25-degree beam spread. So the more intensity you want, the narrower the beam spread, which will give you more light in the center of the beam and not spread the light out. Again, beam spread will be determined by many factors: how much light you're trying to get onto the object, how many feet away it is, and what angle you have. There are many lighting design programs on the web that will help you determine what beam spread is needed for the type of lighting you're doing. Foot candles. Well, lumens out of the lamp. Well, I get that. That's how much light comes out of the lamp. So what's foot candles? Well, foot candles is how much light actually is in the space where the work will be done. And the example to the right says 1 lumen, 1 foot from an object, and that space is 1 foot high and 1 foot long, is 1 foot candle. So foot candle takes the room size into consideration so that you come up with lamp lumens, and then foot candles is how much is getting into the room that you're trying to light. Now there's a number of ways of doing this. You can do it by hand, but nobody does that anymore. You can use a light meter like you see on the lower left-hand side, where if the room is already lighted, you'd be able to measure what the foot candles are. Or you can do a lighting layout and estimate the amount of foot candles that you would get using the source and the fixture. The Illuminating Engineering Society, or IES, makes foot candle recommendations depending upon the task. So if you were filing and you were doing it all day, they'd recommend 30 foot candles. If you were doing light filing and you seldom did it, you were other tasks that you were doing, you only need 10 foot candles. Notice mailing facilities. For security inspection, you're being very critical of what you see. They recommend 100 foot candles. And for building entries, in vestibules where there's not a lot of activity, you only need 7 foot candles or 7.5 foot candles. So these are just 2 categories or applications that the IES makes recommendations for. They're full foot candle recommendations. It consists of about 15 pages of foot candle levels. Let's look at an example of a lighting layout. Here we have a 60 by 25 room with a 9-foot ceiling. The reflectivities of the walls, the ceiling, and the floor are given. We know what fixture we're going to use, a 2x4 that has high output LEDs in it. Each fixture delivers 4,800 lumens and consumes 47 watts, a little over 100 lumens per watt. Putting this information into a lighting layout calculator yields 33 average foot candles. And that is on the lower end of the recommendation, but meets the minimum recommendation. So 15 fixtures will be used in this space, and the calculator also shows what the distance between the fixtures will be, both horizontal and in series, to get even illumination in the space. SATCO has one of these fixture layouts, and there are also others that are available and can be used. What you need is room characteristics and you need the fixture information. And once you do that, you can determine how many fixtures you need for the recommended foot candle level. I'm sure we'd all opt for more light, but does more light mean we can perform our tasks better? Not really. And that's what the IES foot candle recommendations are. It's a range that says if you provide these amount of foot candles, you will be able to complete the task that you need to do or the work you need to do and not suffer any effects with not having enough light. That's one. Two, the more light you put into the space, the more it's going to cost you. And if you need 100 foot candles, that's what you should put in. But if you only need 30, putting 100 foot candles does a couple things. It causes excessive use of energy that really doesn't need to happen. So what's the cost of energy? Well, as mentioned in section 1, you pay for each kilowatt depending on where your utility is in the country and what type of service you have. Here's a bill, and most of them look like this, and they have 8, 9, 10 lines on them, which generally kind of confuses you onto how much does this customer pay for energy. Well, I have a pretty easy way to come out with a number, and that is if you take the total current charges and you divide by how many kilowatts you used, you would come up with approximately, in this case, 10 cents a kilowatt. So you could add these all up, the pluses and the minuses, and come up with that, or how many kilowatts did I use? How much did it cost me? You come out with a number. Cost of lighting varies, and I'll show you that in the next. Here's a state-by-state average of cost per kilowatt. The light blue kilowatt charge is between 7 and 8.5 cents, and the dark blues go from 14 cents a kilowatt up to 30 cents. You can note that the national average is a little over 10 cents a kilowatt. And if you don't know what the rate is, well, you can use the national average, or you can go into some sites that will give you the kilowatt rate for that particular utility. And that generally will suffice. The best thing you can do is what we did on the last slide, and that is get the customer electric bill, because then you'll know exactly what they're paying. But using these guides, you will probably get close. As a review, let's look at the efficiency or efficacy of the light sources that are available and their lumens per watt. Clearly, LED sources have the highest lumen per watt across the board, and they will be the most efficient light source to be used in most applications. So what LED sources are available to replace non-LED sources? Let's start that now. You would think that LEDs have 100% of the sockets in the US. However, they don't. They have about 80%, but there are still plenty of incandescent, halogen, compact fluorescent, linear fluorescent, and HID lamps out there. So you still have customers that are using non-LEDs. And here's LEDs that you can use to replace those non-LEDs. As an overview, SATCO offers a complete line of lamps, fixtures, and electrical MRO items. We have guides for fixtures, for LED lamps, for lighting components, and legacy lamps. We also have our SATCO NUVO decorative light commercial, residential, and hospitality guides. All of these also are available on the web at satco.com. At satco.com, on the website, you'll see categories for light bulbs, decorative fixtures, functional fixtures, components, any support, And later on, we'll talk about tools that you can use to show the advantages of LED. Size, shapes, bases, heights, wattages, lumens. There are not many legacy lamps that cannot be changed out to LED. It's just a matter of unscrewing what's in there now and screwing in one of these LED filament or traditional looking snow cone lamps. LEDs come in all the shapes and sizes that traditional lights have and have been used for many years. And then the snow cone looking LED lights were direct replacements for 40 up to 150 watt incandescent and halogen type lamps. Both Energy Star and non-Energy Star. As we mentioned before, LEDs get up to 90 CRI with a variety of life options. They come in vibration service, damp service, dimmable and non-dimmable, and specialty types with different voltages, longer lives, sensors, and also those that work for plant and aquatic life. There's a full range of PAR lamps from PAR 16 to PAR 38 in spot and flood versions, also BR lamps, ER lamps, MR16s, and anything that was traditionally halogen or incandescent, there's a screw-in replacement with LED. Well, we've come to the end of our second session. A couple of quiz questions. What beam spread has more punch, a spot or a flood? Can all LED lamps be dimmed? Yes or no? Warranties, are there limitations? What are some of them? Are there any applications where LEDs can't be used? Please review and send these questions, the answers to these questions, to your SATCO regional manager. In the next session, we'll review LED replacements for fluorescence, linear and plug-in types, and delivered lumens versus lamp lumens. Thank you.